Hi guys, so today we're going to take a look at question 7 of paper 1 of the 2016 exam. Okay, so air is pumped into a spherical exercise ball at the rate of 250 centimeters cubed per second. Find the rate at which the radius is increasing when the radius of the ball is 20 centimeters. And give your answer in terms of pi. Okay, so, what's the question telling us? Well, it's telling us that the air is being pumped in at 250 centimeters cubed per second. So that's the rate at which the volume is increasing. So we can write that as dV dt. The rate at which the volume is increasing with respect to time is 250. Okay, and so we know we're also working with a sphere, and we're going to talk about the radius. So we have this formula for the sphere. The volume equals 4 over 3 pi r cubed. Okay, now what is it that we're looking for in this question? Well, we want to find the radius, the rate at which the radius is increasing. So that would be dr dt when the radius of the ball is 20 centimeters, when r equals 20. Okay, well, if we're going to find dr dt, well, then we need to have a formula for r. And so we have this formula here, but it's in terms, so r, we don't have r by itself, we have v by itself, but we can use this to get r by itself. So now if we manipulate this, so if we have v equals 4 over 3 pi r cubed, well, if we multiply both sides by 3 and then divide both sides by 4 pi, we will get 3v over 4 pi is equal to the radius cubed. Okay, now we almost have r by itself. So now if we differentiate both sides, if we take both sides to the power of a third, or cube root both sides, then we'll get the cube root, or just the power of a third, of 3v over 4 pi is just equal to r cubed to a third, or the cube root of r cubed, which is of course just r. Okay, so now we have this formula for r. Let's just rewrite it here. R equals 3v over 4 pi to the power of a third. Okay, and now we're looking for the derivative of t. But the problem is we have r in terms of v, not in terms of t. So the way that we can differentiate this is if we try and find dr dt, well, dr dt is equal to dr dv multiplied by dv dt. So if we differentiate r with respect to v and then multiply that by v, the volume, the derivative of the volume with respect to t, that will give us the derivative of the radius with respect to t. And the way that you can kind of see how that would work would be these two almost kind of cancel out here. Now that's not exactly how it works, but that's kind of a nice way of thinking about it. Okay, so we're going to differentiate r with respect to v. So if we differentiate this formula for r, well, first we're going to bring down the power. So we'll get 1/3 by 3v over 4 pi, and then reduce the power by 1. So 1/3 minus 1 is just minus 2/3. And then we have to differentiate by what's inside the brackets. And the derivative of this is just 3 over 4 pi. And then we have to multiply this again by this dv dt here. So by dv dt. So this whole thing equals dr dt. Okay, so, well, how does this help us? Well, we actually know what dv dt is. It's 250. Okay? So now we can write 250 times, well, this 3 and this 3 will cancel. So we'll have 1 over 4 pi times 3v over 4 pi. So this 3v over 4 pi, which is a little bit awkward. But if we notice, we have seen this 3v over 4 pi before. We've seen it here. And so we could just rewrite this as r cubed. Now, you don't really need to, but it's easier. It makes the formula look easier. But you'd be able to do this question no problem without doing this. It just makes our lives a little bit easier. And then this to the power of minus 2/3. And this whole thing equals dr dt. Okay, and now we want to find what dr dt is when r is 20. So dr dt when r is 20, well, we just need to sub r equals 20 into this formula. Okay, so what we're looking for, the dr dt that we're looking for, equals 250 over 4 pi times 20 cubed to the minus 2 over 3. Well, that's just so we notice. If we use our indices law, if we have something to the power inside the brackets, and then that to the power again, you can just multiply the two powers. So this 3 and this 3 will cancel. So it's just 20 to the power of minus 2. And if we put this into our calculator and keep it in terms of pi, we get 5 over 32 pi. Okay, now there is a different way of, so if we just highlight this as our answer. Now this is kind of the more simple way of doing it. We get our formula for r and then we find dr dt. But there's actually an easier way that I want to do, because these kind of questions are fairly common. Okay, so let's just outline this. Okay, so again, we have dv dt is 250. And we have our formula, v equals 4 over 3 pi r cubed. Okay, now what we can do, instead of writing r in terms of v, we can actually just differentiate both sides straight away, and a dr dt is going to come out. Now, what do I mean by this? Well, if we try to differentiate this formula, with respect to t, well then dv dt, kind of like how it was for dr dt, would be dv dr, so v differentiated with respect to r, because that's what we have, and then multiplied by dr dt. And so you see this dr dt term pops out here anyway, even though we're not like directly looking for it, we're going to get it anyway. And then this will give us dv dt in the same way where these two kind of terms almost like cancel each other out. Okay, so now if we differentiate this with respect to r, it's a hell of a lot easier and less algebra to do. So dv dt here would just be bring down the power of 3 and reduce it by 1. So we'll get 4 over 3 pi times 3r squared times dr dt. And now these 3's will cancel, so we get that dv dt equals 4 pi r squared times dr dt. And again, we know what dv dt is. It's just 250. So we get 250 equals 4 pi r squared times dr dt. And now if we want, we could divide across by 4 pi r squared to just get dr dt by itself. So let's do that. Dr dt equals 250 over 4 pi r squared. And you'll actually notice, right, if you look carefully, this is exactly what we got earlier, but this way was, at least I think it was a little bit easier. Okay, and now we're looking for dr dt when r is 20. So if we just sub in r equal 20 here, 250 over 4 pi by 20 squared, we again get 5 over 32 pi, just as we did before. And I probably should have done it earlier. What are the units for this? Well, it's increasing at these centimeter per second. So these are kind of the two ways going about it. The first way is a little bit more direct, and it's kind of a little bit more formulaic, where you're looking for dr dt, so we want to find r in terms of other things. And the other way is a little bit more indirect, but I think it's a little bit easier. Now on to part 2. We want to find the rate at which the surface area of the ball is increasing when the radius of the ball is 20 centimeters. Okay, so what are we working with here? Well, we know that we're working with a radius of 20 centimeters again, and we're looking for the rate at which the surface area is increasing. So we're looking for ds dt, where s is the surface area. Okay, so we have this formula for the surface area. S equals 4 pi r squared. And now we have the same kind of idea as before, where we want to find s with respect to t, but we only have s with respect to r. So like before, we're going to get ds with respect to t, we first differentiate s with respect to r, and then we multiply that by r differentiated with respect to t. And you kind of get this cancelling of sorts. So if we differentiate s with respect to r, we get, well, again, bring down the power and then reduce the power by 1. So we get 4 pi times 2r, and then multiplied by dr dt. Okay, so now we can say that ds dt is equal to 8 pi r times dr dt. And so we'd like to find out what ds dt is when r is 20. And to do that, we need to find what dr dt is when s is 20. When r is 20. Well, we've already just found that. That's what we spent the first part of this question doing. So dr dt equals 5 over 32 pi. Okay, so we can sub that in, and r is 20, so ds dt that we're looking for is 8 pi by 20 by 5 over 32 pi. And now the pi's will cancel, and we get 8 by 20 by 5 all over 32. So we're going to get 800 over 32, which is 25. So we have ds dt equals 25. And now what are the units? Always be careful to get these units in when you're actually working with length. So it's surface area, so we're working with centimeters squared, and again we're working with per second. Okay, so the path given by the ball in the air is described as x f of x, where f of x is this quadratic function they've given us, equals minus x squared plus 10x. So we can insert that in and say that the path of the ball is x minus x squared plus 10x. Now on to part B. The inflated ball is kicked into the air from a point O on the ground. Taking O as the origin, x f of x approximately describes the path followed by the ball in the air, where f of x equals minus x squared plus 10x, and both x and f of x are measured in meters. Find the values of x when the ball is on the ground. So the x coordinate of the ball is just x, and the y coordinate is minus x squared plus 10x. So it's kind of like a parabola shape, which you would expect, when you're kicking a ball. Okay, so we want to find the values of x when the ball is on the ground. Okay, so what do we know about when the ball is on the ground? When the ball is on the ground, the y coordinate is 0. So y equals 0 when ball is on the ground. Okay, well, if the y coordinate is 0 and the y coordinate is minus x squared plus 10x, then we have that we're looking for x such that minus x squared plus 10x is 0. Okay, and now we want to solve for this x. Well, there's an x term here. So if we take this out, we have x by minus x plus 10 equals 0. Okay, so either x equals 0 or minus x plus 10 equals 0. One of these factors has to be 0 for the product to be 0. Okay, so, well, either x equals 0, that's just one value of x, which makes sense. The ball is on 0 when he kicks it, and x is 0 when before he kicks it. It hasn't traveled any distance horizontally. Or minus x equals 10, which means that if we bring over the x, we get that x equals 10. So the ball hits the ground after traveling 10 meters horizontally. So those are the values of x when the ball is on the ground. Now on to part 2. Find the average height of the ball above the ground during the interval from when it is kicked until it hits the ground again. Okay, so we know that the height of the ball is just the y coordinate, so h equals, or let's just say height equals the y coordinate, which is just minus x squared plus 10x. Okay, and we want to find the average of this function over the interval. So the interval is when it is kicked, so when x equals 0, to when it hits the ground again, which we just found is x equals 10. Okay, so whenever you hear the average of a function, you should be immediately thinking of this formula with the integral. So the average of a function is, so the average of a function between a and b is 1 over b minus a times the integral from a to b of the function f of x dx. Okay, so if we sub that in for our case, we're starting off at x equals 0, so a equals 0, and we finish at x equals 10, so b equals 10. And our f of x is just our height function, which is minus x squared plus 10x. Okay, so now we can just sub these into our formula, 1 over 10 minus 0, or just 1 over 10, times the integral from 10 to 0 of the function minus x squared plus 10x dx. Okay, and then we can use this fact. We know from the formulas in the log tables for integrals that the integral of x to the n, it's like the opposite of the derivative. And with the derivative, we would multiply by the power and then decrease the power by 1. And in the integral, it's the opposite. We divide by the power and we increase the power by 1. So this becomes x to the n minus 1, or sorry, n plus 1, because we're increasing by 1, all over n plus 1. And the way you can think about it is the integral is kind of the opposite of the derivative. And if we were to differentiate x to the n plus 1 over n plus 1, we would bring down the power, so we would multiply by n plus 1, and then we would reduce the power by 1, and then we still have this term n plus 1 on the denominator, and then these two would cancel, and we would just get x to the n. So that's how you can see that the integral of x to the n is x to the n plus 1 over n plus 1. Okay, so let's use that. So the integral of x squared will be x cubed over 3, so 1 over 10 times, well, the minus stays, x cubed over 3 plus 10 times x squared over 2 and then all of this evaluated between x equals 10 and x equals 0. Okay, so 1 over 10 times minus x cubed over 3 plus 5x squared. Okay, so if we evaluate this at x equals 10, then we'll get minus 10 cubed over 3 plus 5 by 10 squared. Okay, so 10 between 10 and 0. So 1 over 10 minus 10 cubed over 3 plus 5 by 10 squared, and then minus evaluating it at 0. But because these are just x terms, we just have 0 cubed over 3 plus 5 by 0 squared, and you just get nothing. So we can just ignore that. Okay, so and then this is, and this all equals 50 over 3, which is 16.67. Does it say? Okay, 16.67 meters. And that's the average height.